Welcome to Two Projects. In this video, we are going to see chronic kidney disease prediction using CNN, LSTM and Ensemble Model. Introduction. Predicting chronic kidney disease CKD is essential for prompt treatment and efficient administration. The likelihood of developing CKD can be accurately predicted using CKD prediction models, which examine a variety of clinical, genetic, and lifestyle factors. Such predictive tools not only improve medical judgment but also enable people to take preventive action. The significance of CKD prediction and its potential to improve patient outcomes and public health are explored in this project. Objective of the project. With the help of convolutional neural networks, long short-term memory networks, and an ensemble model with random forest, this project seeks to predict chronic kidney disease CKD. The project entails pre-processing, training, and evaluating the algorithms for accuracy, precision, recall, and F-score using a dataset obtained from Kaggle. The main goal is to create a strong ensemble model that optimizes CKD prediction accuracy, improving medical judgment and patient care. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDLE of Python 3.7 version. To execute this project, we have designed the following modules. The first module is Upload Chronic Kidney Dataset. In this module, the user uploads the chronic kidney disease dataset to the application. The dataset contains various attributes related to patient's health, including both numeric and non-numeric values. The dataset's class label indicates whether a patient has CKD or not. The second module is Preprocessed Dataset. In this step, the loaded dataset is processed to prepare it for training the algorithms. Missing values in the dataset are replaced with 0, and all non-numeric values are converted to numeric format using the label encoder class. The dataset is then normalized to ensure consistent scaling of features. After preprocessing, the dataset is split into training and testing sets with an 80:20 ratio. The next module is Run CNN algorithm. Convolutional neural networks are applied to the preprocessed dataset. CNNs are known for their effectiveness in image analysis, and in this context, they focus on extracting features from the dataset that could be indicative of CKD. The model is trained using 80% of the dataset and then evaluated using the remaining 20% to assess its accuracy, precision, recall, and F-score. The next module is Run LSTM algorithm. Long short-term memory networks (LSTM) are a type of recurrent neural network particularly well suited for sequence data, such as time series or sequential health data. In this module, an LSTM model is trained on the dataset to capture temporal dependencies and patterns in patients' data. Similar to the CNN module, its performance metrics are evaluated. The next module is Run Ensemble Random Forest. In this step, an ensemble approach is employed. Trained features from the CNN are extracted and combined with random forest, a classic ensemble algorithm. The goal is to leverage both the deep learning capabilities of CNN and the robustness of random forest to further enhance prediction accuracy. The next module is Comparison Graph. Here, the results from the previous modules are compared visually. A graph is plotted where the x-axis represents the names of the algorithms and y-axis represents accuracy, precision, recall, and F-score. This graph allows for a clear comparison of the performance of different algorithms. The last module is Predict Disease from Test Data. In this module, a separate test data is provided representing new unseen patient data. The ensemble model is then used to predict whether the patients in the test data have CKD or not. The predictions are displayed giving an indication of the model's real-world applicability. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the dataset folder in which I have kidney disease dataset and test data. I am opening the kidney disease dataset. So here in the first row I have dataset column names, and the remaining rows contain dataset values. And in last column we have class label called CKD and non-CKD. So by using this dataset, we will train all algorithms and then evaluate the performance in terms of accuracy, precision, recall, and F-score. Close this dataset, and this is the test data. which doesn't have the classification column. We will predict the values of that column using trained algorithms. This is the model folder in which I have pickle and .hdf5 files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. This is the Python main code file and this is run.bat file. Instead of executing the program through command line interface, we have created Windows bat file to execute the project. Now double click on run.bat file. A graphical user interface will be opened. With this, we are interacting with the program. We have used Tkinter library to create this graphical user interface. Now click on Upload Chronic Kidney Dataset button. A dialog box opens. Select the dataset and click on Open. So in this graph, on x-axis I have CKD and non-CKD, and on y-axis I have count. So using this graph, we are showing number of CKD and non-CKD patients available in dataset. Close this graph, and in the text area we can see a confirmation that dataset is loaded. These are top 5 rows of the data, and we can see there are null values and there are non-numeric as well as numeric values in the data. And there are 26 columns in the data. Now click on Preprocess Dataset button. So after preprocessing, we can see all the null values are replaced with zeros and all non-numeric values are converted to numeric. And the total dataset is further split into train and test sets in the ratio of 80:20. So previously total dataset contained 400 records, and after splitting into train and test sets, now train set includes 320 records and test set includes 80 records. Now click on Run CNN Algorithm button. So this is the CNN confusion matrix graph. On x-axis I have predicted class and on y-axis I have true class. So these yellow and green color boxes are the true classifications, the correct classifications, and the blue color boxes are the misclassifications. Close this graph, and in the text area we can see the accuracy, precision, recall and F-score of CNN model. Now click on Run LSTM Algorithm button. So this is the LSTM confusion matrix graph. So these are correct classifications and these are misclassifications. Close this graph, and here we can see the performance metrics of LSTM algorithm. Now click on Run Ensemble Random Forest Algorithm button. So this is the confusion metric graph of Ensemble CNN with random forest, and these are the correct classifications and these are misclassifications, and we can see there are no misclassifications. Close this graph, and this is the performance metrics of Ensemble CNN with random forest model. Now click on Comparison Graph button. So in this graph, on x-axis I have the algorithm names, and on y-axis I have the performance metrics, accuracy, F-score, precision and recall. And we can see the Ensemble model is doing well in all the performance metrics when compared to CNN and LSTM models in this particular project. Close this graph, and now click on Predict Disease from Test Data button. A dialog box opens. Select the test data and click on Open. So in the square brackets I have the test data, and after the arrow we can see the predictions as CKD or not CKD. So we can see the predictions for all the test records. So the conclusion here is, this project successfully demonstrated how to predict chronic kidney disease using a variety of deep learning techniques such as CNN, LSTM and Ensemble CNN with random forest. The Ensemble model demonstrated superior performance, achieving a commendable level of accuracy by utilizing a carefully selected dataset and thorough preprocessing. This project not only highlights the potential for cutting-edge algorithms in medical forecasting, but it also emphasizes the value of early CKD detection in terms of patient outcomes and healthcare decision making. Thank you for watching this video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.